So hi everyone, and welcome to the NANOG 92 Hackathon introduction. Hope you're all doing well and excited to participate in Toronto. First, we'd like to thank our in-kind sponsors. Each one of these organizations and their project has helped fulfill the hackathon's mission. So overview of the hackathon. First and foremost, NANOG's educational mission. The hackathon is part of this educational mission of NANOG. Our goal is to provide this experience such that knowledge can be shared amongst participants to help foster new ideas that will help the community and the participants learn and grow. All times will be provided in Eastern Daylight Time, UTC -4. A slight change to the format this time around. We will be running the hackathon in parallel to the conference at NANOG 92. Remote participation is okay. I know some of you have emailed about us regarding those kind of questions. Our goal is to essentially boost participation by having the hackathon run in parallel to the conference, getting more people involved, letting people have a bit more time to get on site. As basically we used to always run the hackathon on Sunday. It might be more comfortable for people to just participate in all NANOG activities for the primary Monday through Wednesday format of the conference. So you can see a date and timetable there. October 21st at 10 a.m., the competition will begin. That is Monday. October 22nd at 6 p.m., competition will conclude. That's Tuesday evening. And October 23rd at 4:30 p.m., we will be on stage at the general plenary session, going over scores and prizes. So how do you interact with the hackathon and the community? So Slack is the primary way to get help and updates. Everyone that is a part of this call that is registered for the NANOG 92 hackathon should be a member of the Slack channel NANOG-92-hackathon. We ask that you can use the @mentors mention keyword to reach any of the hackathon support staff. Along with, we ask that you do not use @here or @channel, as those can be distracting notifications. We want people to be as engaged in the challenges as possible with minimal distractions. And then having an up-to-date Zoom client is a good idea. We primarily use Zoom for this introductory call. We will as well have Zoom streaming. In the past, we've had Zoom streaming in the room on Sunday. However, given that we'll be running in parallel to the conference this time around, there will be a support desk where hackathon support members will be generally available throughout Monday and Tuesday. You should be able to find that near like the coffee and snacks and general registration. But yeah, for the most part, Zoom is just used for this introductory call. All right, so the theme. It is similar to the past 2 or so hackathons that we've done, where we are giving you a variety of network problems and challenges to solve. So each is in the format of a scenario, which will have an objective of fixing something that is broken that requires, some degree of troubleshooting to resolve. Each scenario will have challenges within. And the goal is to complete each one of those challenges to score points. In terms of infrastructure, each scenario will have a collection of routing devices or some number of hosts pre-configured in a topology. And your goal is to effectively resolve any issues with that infrastructure or scenario. And when it comes to scoring, so each scenario will have a collection of challenges, each with a point value. The first person or team to submit correct answers to all the scenarios wins. A tie will be broken based on time submitted. Scenarios are not expected to be done in a specific order. However, their embedded challenges may expect an order of completion. They may not as well. So we will be giving out one prize on Wednesday, effectively to whoever scores the most points in the shortest amount of time. Like I said before, a tie will be broken based on time submitted. If there aren't any questions with that, I'd like to defer to my colleague, Chris, who's going to talk a little bit more about the infrastructure.
So hi, I'm Chris. I'm part of the Hackathon committee, and I'm here to talk to you a little bit about Container Lab and how we use Container Lab here at the Hackathon. Each team or individual hacker or team, if you create a team, will have an AWS EC2 instance that we will provision for you if you as on request. So if you have a scenario that requires it, get in touch with us and we will provision this for you. Um, the scenarios, there's a GitHub repo that documents the various scenarios that have Container Labs, so you can see the topology files in that repo as well. Each of the instances will be accessible using an SSH key that we will provision. We will publish to the Hackathon Slack channel. We're all adults here, so please, no, please don't do anything nefarious with that because it is shared infrastructure and everyone has the same key. So we trust you here. No cheating or hacking other people's instances. The instance will have a static v4 and v6 address for access, and then you can SSH into the instance and interact with the router and servers as well. One mechanism is that you can create an SSH port forward on the device. So you can create an SSH tunnel from your local device to the containerized instances. The other technique, the easier one in my opinion, is to log into the EC2 instance and then use either Docker exec commands or SSH to access the containers. Different scenarios may have different topologies. This is an example of one that we built. As you can see, this particular one is v4 and v6 dual stack. And you may see a variety of different network OSs. This one in particular has CEOS, which is Arista EOS, and then CRPD, which is Juniper's RPD, containerized RPD. So just be ready for various vendors. You'll most likely those will be the only two you see most likely, but scenarios could have other devices as well. So in order to access the device, we'll publish the key. You'll want to copy that key into your .ssh directory. If you're running Mac OS Linux, with Windows, there you can I believe using PuTTY, you can point to that SSH file using the command a menu item or a menu option. Important point is that you need to make sure that the key is only readable by user. So mode 600. So make sure that you do that. Otherwise, SSH won't load the key, and then use that key file to authenticate to your instance. Here's a quick example of what that looks like on a command line. Export a environment variable for the key's file name, so that I can copy the key over. You see mod SSH, and then using the SSH-I argument, which allows you to point to a specific private key. Important note is that these instances, the username is Ubuntu, because these are EC2 Ubuntu instances. So that's your username that you're going to use when you log into them, and then you can see the MOTD that you get when you log in after logging into that device. So once you are in, you will want to move to the opt CLab directory, which is where the scenarios will live. And if you look at if you run the CLab inspect command, you can see the devices here. Actually, they all show up as exited for some reason on this, but if they were alive. So to access device, Docker exec is generally the easiest thing to do. If you ever use Docker, this should be familiar to you. The important thing is that for CEOS, there is an executable for the router environment. It's called CLI, and it's a capital C. So that's what you'll want to run. If it's an Ubuntu, Linux, Bash is the basic. Make sure to run Bash, and then you'll get a Bash prompt in those containers. So here's an example of what that command looks like. That is one of the routers in the scenario. And then you can see get the CEOS router prompt, move to enable, show version, and then you can see it's the containerized Arista CEOS. If you're not familiar with Arista, it's pretty straightforward. Most of the commands you're going to find are going to be very similar to Cisco Classic iOS. One thing to note if you're using configure commands is that there is a session configuration session that's very similar to Juniper's configure mode. You run configure session, you enter in the configuration commands, and then you use the commit command to actually instantiate those. They don't take effect as you type them with classic iOS style. Um, you know, unlike Junos, you still need to hit write mem afterwards. And the commit does not actually save the command changes, so that saves you from, that allows you to recover if needed. There's a documentation link for Arista's configuration syntax, and of course, we'll be around to help you if needed. So I'm logged into an EC2 instance right now, and the one thing that you might want to be interested in seeing is what the actual topology file looks like. This is a fairly basic topology, and we've got two Docker images defined. So if I get out of this and run Docker images, you'll see images with this name, COS, and then a customization of an Ubuntu that we use for these containers that we've been using for the past couple hackathons. The topology has a default startup config for each of the containers. And if you were to SSH to them directly, these are the IP addresses that you would use. So these get assigned, and this is a virtual management network on the host. So you can create an SSH tunnel through the EC2's IP to these, and you should be able to reach those directly from your desktop if you need to be. So we've got 4 CEOS nodes defined. We have the 2 Linux hosts defined, and these are shell scripts that create the necessary routing entries on those hosts, so that if this topology was fully operational, you'd be able to ping from host 1 to host 2. So we have Docker style file system bind, and then an exec to actually run that cell command. Down here is as a definition of how all these hosts connect to each other. So each of these entries defines a link between 2 hosts. So if you look at the topology that we've published, you'll see how this maps. So, and if you want to edit these files, you can. The instance is yours to do with your please. If you get too messed up and need a refresh, and need one refresh, just talk to us and we can reinstantiate you a replacement image with the base build. So a couple commands to be familiar with. So I have a running topology right now, and if I wanted to reconfigure this, I would use I think it's the update command. Now you always need to reference the topology file, and in the scenario, in the repo, there may be multiple topologies, so you'll need to deploy different topologies as you go. If you ever update the scenario file, the topology file, so update is the command you want to. Did I miss it? I may be committing a presentation faux pas. I thought it was update config. Okay. No, not config. Let me get back to you on the right command, because I thought it was update.
I think you mean reconfigure.
Reconfigure? That's not it either. Okay, apologies. I'll look that up and posted in the channel. But you can destroy you can redeploy a topology fairly easily. You just need to destroy the existing one first and then run the deploy to recreate it. So if I run the destroy command, and you'll see there are no containers running. Now, if I do this, I'm sorry.
Sorry, it was a double hyphen reconfigure.
Oh, okay. Is it under deploy?
No, and well, let me. Yes, it's under deploy. Sorry, yeah, under
Okay,
deploy
okay,
hyphen reconfigure.
okay. That was my mistake. So, and then to create a new topology, the deploy command is how you would do that. So this command here is creating everything. This takes a minute or two to bring up. We're spinning up, we're booting up 4 instances of Arista CEOS within containers, so that takes a little bit of time, but not too long. And the 2 Linux containers as well. Yeah. Container Lab, there's documentation like we can put in the channel. And there's a lot of really interesting things you can do with Container Lab. It can actually automatically create flow topologies for you if you ever want to lab up virtualization. It supports a large number of virtualized OSs. There's a number of available OSs that are containerized. It also supports virtualized OSs. The VM effectively runs inside the container. So there's a pretty long list here of what you can deploy using Container Lab. And I believe there's a workshop. There's a workshop during the meeting on Container Lab as well. That I believe our friends at Nokia are running. So unfortunately, we can't do nested virtualization in AWS. So we're in the context of running a VM already. We're limited to the container-based options. Okay, so our lab is now deployed. And then if I wanted to log into a device, CLI. Okay, I'm in the device. Do show version without having to go to enable. And if I go to enable, I can get the configuration, which is this is a Arista configuration syntax, and yes, it does look a little bit Cisco like. See, our BGP sessions are up both on V4 and V6. We've got a full routing table. We can ping across devices. And you can just use this like you would a physical lab in every other aspect. So there's a V6 routing table as well. So and like I said, we'll be in the Hackathon channel. We'll be manning the desk, so feel free to come to us if you have any specific questions. I'll be around to help out as best I can. Any questions? Okay.
Cool.
Thanks. Back to you, Aaron.
So I just want to remind everybody again of something that we're doing differently this time around is that we won't have a room on Sunday. We will be running in parallel to the conference starting on Monday morning. Remote participation is okay. There will be a support desk where you'll be able to find one of us and ask questions in person. Or likewise, if you're participating remotely or just for whatever reason can't be near the conference at a certain point in time, feel free to message us over Slack. And then don't forget that at 4:30 on Wednesday, we will be doing scores and prizes on stage in front of the entire conference. We're excited to see you all participate in about a week's time. So I hope to see you soon in person. If not, hear from you remotely, and wish you all a good weekend. Thanks, everybody.